I'm going to try to take you through a visual aspect of a sheep brain dissection, even though we're not in the classroom where we get the actual physical aspect of it. Now, if you want the physical, take a fully ripe plum and squeeze it in your hands just a little bit. And that's kind of what a brain feels like. If you want the smell, you're going to have to really go to a landfill or something that's pretty bad. But, and then if you peel that plum in to where the peeling is very much intact, you will feel the the peeling is similar to the dura mater that I will show you shortly, though not as tough. If you look here, it's very small in the frontal lobe area. Now, the reason it is very small in the frontal lobe area is because sheep are dumb as dirt and they don't need to do calculus. We do our calculus up here. Sheep need to do one thing, and that's eat, take it easy, grow wool or something. Not much. Okay, now someone has dissected the bottom part of this brain, the dura mater off, done a very, very good job on it. So now we have our olfactory bulbs. Olfactory, think about a stinky olfactory. The olfactory is for your sense of smell. Olfactory bulb, olfactory tract, and these have sensors are directly in the dorsal aspect of your nose. Here we have our optic nerve again, optic chiasm here where it crosses over, and some of the visual processes cross over in the eye and some stay on the same side. It's all processed back in this part. These are oculomotor nerves, and they do just what you think. Oculo, eyeball, motor, moving. Has to do with eyelids, pupillary constriction, and that type of thing. Now, this is your pons, medulla oblongata. Medulla oblongata is very important for controlling respiration, for controlling fine-tuning the heartbeat, though the heartbeat has its own motor, its own electrical impulses. And then you go into the brainstem and spinal cord. And I think that's about what we have to look at on this slide. See this transverse fissure? Now what someone has done is they pointed this straight at them and then bent this cerebellum down. It's bent down. And you can see the this little section here, it's got 4 little parts, so it really looks like 2. Bump, bump, with a little bump on top. And this is called collectively the corpora quadrigemini. This is the inferior colliculus. You have your left and right side. This is a superior colliculus, your right and left side. And they have to do with processing sound and sight, vision, just fine tuning it. And then up in here, you can barely see the pineal gland, and it makes melatonin. So they've just basically cracked that lobe at the transverse fissure. Here you see your longitudinal fissure on the top of the brain. Okay, this brain has been cut straight down the longitudinal fissure, which gets you the left side of your brain, the right side of your brain. Makes it easy to see what the inside looks like. Now, right here in your cerebellum, it's easy to see gray matter versus white matter. White matter is white, and gray matter is really not gray, but it's sort of a tan. Now, if this were fresh tissue, and some of my paramedics and EMTs can probably tell me more how gray it would be, this absolutely has no vascularity because it's dead. But anyway, this is the white and the dark. Now, in the cerebellum, the white matter, it looks like a tree, and it has the name, the Latin name, arbor vitae. Arbor means tree, vitae means life, so tree of life. To me, it looks more like cauliflower than a tree, but I didn't get to name it. Okay, here is our cerebrum, which is the main thinking part of your brain, your frontal lobe, uh, parietal, occipital lobe here. This round section here is the thalamus. And if I had been on top of things, I would have artificially made that more visual because it's very obviously round. Now, I've mentioned in some of my lectures that I know you've all already listened to that everything that goes from the bottom part of the body, you know, your foot, your hand, the peripheral part of your body, to your cerebrum has to go through the thalamus. This is a filtering system, and it decides what goes on up to be processed and what's ignored. And apparently, if you do not have a normally functioning thalamus, then you pay attention to everything. And that's one thing that goes wrong with when you take LSD or hallucinogenic mushrooms, is your brain no longer filters out the bad stuff, everything, and you perceive everything and your brain can't process it. And so therefore you see camels walking out of the wall or whatever it is you see. I never tried it myself and would not plan to. But this is the thalamus, so immediately below it is the hypothalamus, and then under here, what you have on your brains, we're not doing brains, that's right, but you have mush. But what's supposed to be there is the pituitary gland, and it hangs down on a stalk called the infundibulum. This, you recall, is your superior and inferior colliculus. This is your pineal gland, and generally you only find it stays on one side when you cut these in half. The pineal, everything else has a left and a right. The pineal gland, there's only one of. And Rene Descartes, the philosopher, said that the pineal gland was the seat of the soul. And because there was only one of it, and if the soul was divided, then humans would be mad, and that humans weren't mad, and so obviously that was the seat of the soul. He was wrong in two ways. I think humans are pretty mad, and also that has nothing to do with the soul. If they're, you know, that would, if you had a physical soul, it would have to reside in your cerebral cortex. But this is the it just makes melatonin. When it's dark, it makes melatonin. You get sleepy. When it's light, it does not make melatonin. Okay, now to connect the left brain and the right brain, you have this thick piece of white matter called the corpus callosum. Then underneath it, you have the fornix. And I think I got better pictures on the next page. When they did the frontal lobotomies back in the 30s, 40s, 50s, and to try to control absolutely insane people that could not be controlled any other way, what they did was ran a little pointer thingy up through their nose and went up into the brain and doodled this out. And when I say doodle, that's what they did. They didn't do any fine surgery. They just split up the brain's two halves, the front part of it. And it took them from being a crazy person bouncing off the wall into being a easy to subdue, docile individual. I think I would personally rather bounce off the wall. Okay, as we go here, you see this instrument has been put in between the corpus callosum and the fornix. There was over here a little thin sheet of tissue called the septum pellucidum. When you break that, it takes you to the lateral ventricle. And you can see all the other structures we've talked about. Okay, this, of course, your transverse fissure, your arbor vitae. Here you have a really good view of your thalamus, hypothalamus, pituitary, not so much. This is a good picture because we've taken, and one of my students did this. They had these different colored pens, and they put the blue into their pineal gland, the red one into the thalamus. So under hypo is under the thalamus, is here. And then into the lateral ventricle, they put the green one. Again, you see your arbor vitae. It's just the same things over and over again. And this has got a whole bunch of stuff labeled. Nothing really that terribly new from what we've done. I don't think I mentioned pons. I don't know why I didn't, probably because I'm doing this off the top of my head. But pons, medulla oblongata, and then this goes into spinal cord. And what defines where you leave the hindbrain, the medulla, and go into spinal cord is where the mark, where you go through the hole on the bottom of the skull, your magnum, foramen magnum. Oh, God, don't you hate it when that happens? I'm believing it. Okay, pineal gland. So I always wondered about the foramen magnum. If you lift your head up higher, does that mean that your spinal cord goes up and you change what's spinal cord and what's not? But if you have this part of the spinal cord severed, respiration stops, the end of project, end of life. Here you have neatly labeled the fornix. Okay, this, I believe I wrote the end there where I wouldn't get mixed up. This brain, we sliced it into, well, ended up getting sliced and sliced and sliced just for the purpose of someone wanting to massacre it, I think. But you can easily see all the white matter running throughout the brain and here, and then this is the gray matter. So you have in a brain, you have the cerebral cortex and the cerebellar cortex have got gray matter, but also within the brain, and I don't have a picture that's adequate to visualize that, but the basal nuclei are little sections of gray matter that are within the white matter in the middle of the brain. And you just see blobs here. I always said when I took neuroanatomy, it was like labeling a balloon. And I think the biggest thing that we miss out on these brains without having real human brains is that they're so squashed that you don't even see the pituitary gland. Thalamus is lovely on this one. Hypothalamus here. This is the end of the show, and hopefully this time it will work.